So I'm going to put the link in the live chat, or in the chat for you guys, if you guys want to watch it on YouTube. And device settings. I want to make sure my audio is linked up. Audio. All right. I'm hoping the delay with the audio and video is not that bad. Okay. So what I'm going to do is I'm going to go ahead and get rid of my face so you guys can still hear me. All right. So does everybody understand what we're doing? We have a car that starts from rest and it travels a distance of 300 meters in the time frame of 1.5 minutes. And I'm asking, what is the velocity at this time? So when we are doing these problems, the very first thing that we do is we rewrite the problem statement. Okay, so this is the problem statement. And like when we're in the classroom, I will have a template that you guys can follow to help guide you guys through this. But for right now, let's just go through the problem and see where there's any values, okay, any numerical values. So the first numerical value that we get to is 300, and it has units of meters. So I'm going to go down here to my knowns, and I'm going to write down 300 meters. Now, if we go back to, now you guys can have this document up. It's uploaded on Canvas in the modules. So if we go to the first page, we know that down at the bottom in the red box, I have d is my displacement, and that has units of meters. My initial velocity is v sub I, and that has units of meters per second. My final velocity is v sub f, which also has meters per second for the units. A is the acceleration, and that's meters per second squared. And time is t, and that is units of seconds. Okay? So that's going to be important in the next couple minutes. So if I have units of 300 meters, which variable in the red box should that go with? The 300 meters. What should that be associated with? If I have 300 meters, meters is a unit of length. So we're going to have d being 300 meters, my displacement. Luis, are you watching it on YouTube Live, or are you watching it through Google Meet? All right, there's Jordy. Give me 1 second. I'm going to get Jordy in here. Okay. How about this? Thank you, Sakura. So if you have your phone, okay. So if you have your phone, you can pull the live stream up on your phone so you can hear me that way. Okay. So we've already gotten this here. And then the time that it takes to travel this distance is going to be 1.5 minutes. All right. So obviously that's going to be a time. It's going to be 1.5 minutes. But time has to be in units of seconds. Okay. So 1.5 minutes is going to be how many seconds? I mean, 90 seconds. Okay, cool. So we're going to temporarily cross this one out because we're not necessarily going to use that, even though it is something that we're given. I'm going to temporarily cross this out, and that way we can just look at the one that we are going to use. Okay. And then there's actually another piece of information in here that they're giving us as a known. Does anybody know what that's going to be? So a card starts from rest. So if something is starting from rest, this is telling us that our velocity is going to be equal to 0 meters per second at that time period. Okay. So in this case, since it's saying that it starts from rest, then that means that this is going to be our initial velocity. Does that make sense? So by saying that it starts from rest, and I'll include all of that. How about this? If it starts from rest, our initial velocity is equal to 0 meters per second. Okay. Even though there's no number given, if we read the problem correctly, it can give us information. So with that, I'm going to put this down here. So my initial velocity is 0 meters per second. Cool. So we've got displacement, we have time, and we have initial velocity. That's what we're given. Cool. Now, what is the problem asking for us to find? It's asking, what is the velocity at this time? So, in other words, what is the velocity at 1.5 minutes? So, obviously, it's going to be a velocity. And since we've already utilized initial velocity, the only one that makes sense would be final velocity. So, it's asking us to figure out what our final velocity is. And this is going to be in units of meters per second. Does that make sense? Is there any confusion so far? If you're confused, this is the time to ask me. Don't make me start calling people out, because I will. So the reason why I crossed out this one is because the 1.5 minutes is the same thing as 90 seconds. Like, we were given the 1.5 minutes, but we can't use the minutes in our equation. We can only use seconds because that's the base unit of time. So that's why I crossed it out. Even though these are the same thing, I crossed it out because I don't want to get confused. Make sense? Okay. So what my objective is now, I need to find an equation that is, well, I need to find an equation that has my final velocity, my displacement, the time, and my initial velocity, and no other variables. Okay. So if we look at our equations, whoops. If we look at the equations that I've got over here, I need this I need an equation that has displacement, initial velocity, final velocity, and time. So which one of these equations has all 4 of those variables? We'll say equation 1, equation 2, equation 3, equation 4. Yeah, so it'd be the 4th one. So the reason why we can't use the first 3 is because all of those have the acceleration in that problem, in that equation. And we don't have a value for the acceleration. So this is the only one that's viable. This is the only one that we can use. And luckily for you guys, if you scroll all the way down to the last page, this equation I solved for you algebraically for each one of these variables. So you guys don't have to do any of the algebra. So the variable that we're solving for, if I switch back over here, is going to be the final velocity. So I look for an equation that has final velocity in it. Okay, it's final velocity equals. And even if you don't know which equation to use, because I've already done the algebra for you, you can scroll through all of this and look for equations that are V equals. So this is a V equals equation. Or sorry, V sub F equals. This is a V sub F equals, but this one has acceleration, so I can't use that. This one's a V sub F equals, but this one also has acceleration, so I can't use that. And then this one doesn't have a V sub F in it. Makes sense? So that's another way to kind of limit which equations you can use. So we're going to use this final one down here because we're trying to find V sub F. We know our displacement, we know the time, and we know the initial velocity. Make sense? Okay. So if I go back to here, all right. So the equation that we have is going to be V sub F. Oops. Equals 2 times my displacement divided by the time minus my initial velocity. Cool. Now, before we start plugging values in, and I did not make this proper size. Okay, there we go. That's better. So before we start plugging numbers in and start doing the math, let's make sure that this is the right equation. So on the left side of the equal sign, the only thing that should be there is the variable that I'm solving for. So I had a check mark for that because V sub F is on the left side by itself. On the right side of the equation, I should only have variables that are located in my knowns. Okay? I should not have a variable over here that is not located over here. So I have displacement. Good. Do I have time? Yep. So that gets a check mark. Displacement gets a check mark. And velocity, or initial velocity, I should say, I get a check mark for that. So if I have all check marks over here, then I'm allowed to plug in my values. Okay. And just to make sure I do everything correctly, I'm going to copy down my equation over here. Now, I've mentioned before that this may seem tedious, but I promise you, if you follow these procedures, this will save you a lot of frustration and heartache when you realize that you forgot a square or you made something positive when it should have been negative. By copying it down and making sure that you copied it down correctly, it'll save you a lot of grief. Okay. So once I've written down the original equation over here, anywhere that I've got variables on the left side, or on the right side, I should say, I'm going to replace those with empty parentheses. So that's the one for D, for displacement. This is the one for time. And then this is the one for initial velocity. Now, I'm going to look back up at my knowns box, and then I'm going to start plugging in. Because I've already verified that this is the correct equation to use. So my displacement is 300. The time that it takes, it was given in my problem as 1.5 minutes, but we can't use minutes. We have to convert that into seconds. So I'm going to do 90 seconds. And then my initial velocity is just going to be 0. Cool. Is there any questions so far? Is everybody good? Okay. So I'm going to have, so 2 times 300, I get 600, divided by 90, minus 0, so I can just leave that off. So 600 divided by 90 will give me approximately 6.66 meters per second. That's my final velocity. So the 90 was from the 1.5 minutes. Does that make sense? So I converted the 1.5 minutes into seconds. So in 2 minutes, it's 120 seconds. In 1 minute, it's 60 seconds. So 1.5 minutes is 90 seconds. Does that make sense? Okay. Do you have your phone? Um, oh, is that better? Okay. Um, Alberta, what do you mean by time? Yeah, he said that he is having oh, gotcha. Um, he said that he's having internet issues. Okay, so 300 meters in about a minute and a half. So the final velocity would be that. Cool. All right. Is there any question about that? Okay. So, and then again, make sure that you box your answers like that. Cool. All right. So let me do this. All right. So we're going to do another problem. Um, but in this case, we're going to have some different information. Come on. There. So this is kinematic equations. Or kinematic example. Okay. So car starts at rest, accelerates at, we'll say, 5 meters per second squared. And over a distance of, we'll say, 500 meters. Let me clean that up a little bit. Okay. So I have a car that starts at rest, and then it accelerates with a value of 5 meters per second squared over a distance of 500 meters. So I've got my knowns, my find. I apologize about the trash truck outside. And then my equation. All right, so just like before, we are going to go through and figure out what we're given and what we need to find. So if a car starts at rest, that tells me that my initial velocity, v sub I, is equal to 0 meters per second. And I want to be consistent, meters over seconds. And then it accelerates with a value of 5 meters per second squared. And then it goes a distance of 500 meters. So I do not have to convert any of my given values because they're all in the base units. Okay, so just as a reminder, if I switch back over here and I scroll up to here, let me zoom in just a little bit. So displacement is in meters, which I've got here. So that's in meters, so I don't have to change that. Velocity has to be meters per second, and acceleration has to be meters per second squared. And that's what I've got over here. It'll switch. There we go. Velocity, meters per second. Acceleration is meters per second squared. Now remember, with acceleration, what that's telling us is that my velocity is going to be increasing by whatever magnitude my acceleration is, whatever the numerical value of my acceleration is. My velocity, my speed, is going to be going up or down, depending if it's positive or negative, by that amount every second that passes. Okay? That's all the meters per second squared is. It's meters per second per second. Cool? So, that's what they've given us. And then we need to and I forgot to write what we were trying to solve for. Okay. So how fast is it going after going, or I should say traveling? after traveling 500 meters. So it's asking us, what is our final velocity? Cool. What's up, Sakura? You good? Sorry, I forgot to to put the whole point of the question. Like, what is it asking? All right, where are you lost? Like, this is the time to ask me. Are you confused about this part, the find and equation part? Okay, so that's what I like when I came over here to the find part. I forgot that I didn't put this part of the question in. The whole point of the problem is to figure out some value. So it's asking how fast is it going after traveling 500 meters. Cool. And after 500 meters, that's gonna be my final velocity. So that's where I got this part. Now the equation part, without knowing what equation to even use, like without even just the basic knowledge of which one of these equations I'm going to be using in general, what you guys can do with my document that I've uploaded on Canvas is look for any equation that is already solved for v sub f. Okay, because I've already done all the algebra. So I want something that only has v sub f on the left side. Cool. So if I switch over back here, would this equation be useful? Does this one right here have v sub f by itself on the left side? No. Why does this one not have v sub f on the left side by itself? What's also on the left side? The square. Yeah. Okay. So we're going to hold on to that because, I mean, it does have my initial velocity, it does have acceleration, and it does have displacement, which are all things that we know. This one we definitely cannot use because we don't know anything about time. And this thing here, we don't have time. We don't have time. So this would be the only equation that we could use because we have all the other variables, but this isn't quite the way that it's supposed to be set up. You guys checking? You understand what I'm saying? So let's scroll down to the page 3. So this is the equation that I was just referring to. Now, all I did was in order to get rid of this square, I took the square root. Okay. So if I do, let me just show you real quick. If I have x squared, in order to solve for x, I have to square root, and that's going to cancel with the square. And then I'm only left with x. And the opposite can also be true, where if I have, instead of x squared, if I have the square root of x, what I can do is I can take all of this and square it, and I would still get x. Does that make sense? So in order to get rid of a square, or in order to get rid of a square root or a radical, I can square the whole thing, and then the square root and the square cancel. Or if it's already squared, I can just take the square root, and then the square root and the square go away. Okay? But for right now, you guys don't need to worry about that because I've already done the algebra for you. Okay? So that's how I went from this equation here to this one here. I took the square root of both sides, so the square over here canceled. So I'm only left with v sub f, and the square root is over on the left or on the right side. Okay? Is there any questions so far? Okay. So this is the equation right here that we're going to be writing down on our sheet. So I'm going to have v sub f, change the color, and I'll switch back after I write this. So I'm going to have v sub f is equal to the square root of v sub I squared plus 2 times the acceleration times my displacement. So that's the equation that we're going to use. And then just by looking at it, I can go ahead and verify that v sub f is over on the left side by itself, which is what I want to find. So that gets a check mark. And then v sub I, a, and d, I have v sub I, a, and d. So this is a valid equation that I can actually use. Now, one of the reasons why I'm live streaming this on YouTube Live is so you guys can go back and watch this. If you're kind of zoned out right now, I understand. It's Friday. It's the day before Halloween. I totally understand if you're kind of zonked right now. So that's why I'm providing it for you guys online so you can go back and watch this. I'm hoping that my sweater is not making a lot of noise because it is jingly. All right. So okay. Yeah, and like after this, we're gonna call it a day. Like after I finish this one, so I know you guys have a lot of work to do too in other classes. So I'll finish this up real quick. Okay. All right. So once we get our equation rewritten, I'm going to now leave open parentheses wherever my variables are. So v sub I, a, and d. I'm just going to put empty parentheses there as placeholders. That way I know that I'm not messing anything up. Okay. And then I'm going to plug in my values. So v sub I that was weird. Interesting. What do you mean by a 4-day weekend? Do we have a 4-day weekend? You all hear me? Testing 1 2. Oh. How was I not made aware of this? Oh, that's right. Yeah, because you guys have. Hold on. All right, I'll look that up later. Let me finish this up. Um, okay. So y'all can still see my screen, right? Okay. Um, so the 5 came from the acceleration over here, and then the displacement is going to be 500. Okay. Now all I have to do is I can either put it in the calculator just like this. So let me show you what that will look like real quick. So I do the square root, and then it's squared plus 2 times 5 times 500. Let me get rid of these. So it would look like this. 0. Here we go. Switch the cam. So it would look like, come on, like that. Y'all can see that. It's moving backwards for me. So the square root is over top of everything. So I get approximately 70.7. So sometimes you guys will see me do like an equal sign with a little tilde on top to mean approximate, or you'll see me do little curvy equal signs to mean approximate. So I'll say 70.1. So approximately 70.1. That was not an M. Meters per second for my final velocity. Sorry. And then, of course, finally, box your answers. Okay. So after doing like 2 or 3 examples total, how do you guys feel about doing problems like this?